Hello my friends, welcome to my channel. It's around 6:50 in the morning, and a very good time to learn mathematics. So welcome to my channel, Maths and Stuff by Samson Paul. And in this video I'm going to discuss with you a few problems on how to solve uh, how to differentiate using trigonometric identities. And normally when you have trigonometric functions like this, uh, you tend to use, a lot of my students tend to use, I wouldn't say everybody does it, but a lot of my students tend to use u by v rule, that is the quotient rule, or u into v rule, that is the product rule. But essentially these types of using these types of rules uh, can are not required and can be smartly avoided by certain trigonometric identities. So let's start without any further ado. Let's start the problems. I'm going to discuss the first problem, how to do it with you, that is y sine x. So differentiation is you have to find the differentiation of y equal to sine x by 1 plus cos x. Now if I were to differentiate this using u by v rule, I would get the answer. I wouldn't say I wouldn't get the answer, but that's not actually one of the right ways to do it. So the right way is very simple. You just understand the formula, two formulas that you are supposed to know. The first formula is sine 2x. Sine 2x is nothing but 2 sine x cos x. Okay, sine 2x is equal to 2 sine x cos x. Now how do I use this formula here? Now in place of 2x, if I put x, okay, sine x, okay, in place of 2x, if I put sine x, if I put just sine x, then this would mean 2 sine of x by 2 cos x by 2. Okay, and these kind of formulas are called as half angle formulas. Okay, and so this is how you solve these problems. There's also problem for 1 plus cos x in half angle formula, and that is 1 plus cos x is directly 2 cos, it's a direct formula, 2 cos square x by 2. Okay, and this is how the formula is directly. So while solving this problem, instead of using the u by v rule, what you can do is you can do one substitute for sine x, that is 2 sine x by 2 cos x by 2 divided by 2 cos square x by 2. Okay, 2 cos square x by 2, and that is nothing but 2 and 2 gets cancelled, and the power of sine will get cancelled. You will get tan x by 2, and the answer is y equal to tan x by 2. Now I can differentiate y is equal to tan x by 2, and I will get the answer. Differentiation of tan x is secant square x, but there is a half by 2 here, so it is nothing but half of secant square x by 2. Pretty simple. Okay, and let us go to the next problem. Okay, so basic rule here is rule here is that you use some form of trigonometric identity to solve the problems. You have to use some form of trigonometric identity to try to reduce it. If it is not reducible, then only then you look for alternative methods. Now let us look at this problem. Y equal to sine x into cos x, right? Now most of you, even including me, I'm tempted to use the chain rule, or I'm also tempted to use the product rule. Okay, you can use product rule, I wouldn't say you can't. You can use, definitely you can use product rule, but it doesn't, you know, add up to anything. So if you are quite vigilant throughout this video, or you have a good hold on trigonometric identities, you will remember that sine of 2x is nothing but 2 sine x cos x. That is nothing but sine x into cos x is sine 2x by 2. Okay, so I can write this in terms of sine 2x by 2, and that will give me y equal to sine 2x by 2, and that is nothing but y equal to half of sine 2x. Okay, and now this can be easily differentiated and written as y is equal to dy by dx is equal to differentiation of sine x is cos x or cos 2x into differentiation of 2x, which I will write it here, is 2. 2 will get cancelled and you will get cos 2x. As simple as that. Okay, then for the last problem, okay, might look a little bit complex. That is this problem. Okay, so what I'll do is I'll copy it down so that you have a particular space to solve it. It might look a little bit complex, but actually this problem is actually very easy to solve. Again, you have to be thorough with trigonometric identities for this one, and a trigonometric identity that can be used is actually 1 minus cos x is nothing but 2 sine square x by 2. Okay, and 1 plus cos x is equal to 2 cos square x by 2. Okay, cos square x by 2. Now if I substitute this formula here, I will get it as y is equal to 2 sine square x by 2 divided by 2 cos square x by 2. X will get cancelled and I will get it as tan square x by 2. Okay, now here you can actually directly solve this applying chain rule, that is 2 tan x into differentiation of tan x by 2, that is secant square x by 2, or you can use the trigonometric identity 1 plus tan square theta is equal to secant square theta. Okay, you can do this too. It's perfectly up to you. Both will lead into the same answers. Okay, all you have to do is secant square minus 1 and you can do it. But I'm going to use the chain rule in this thing. So dy by dx is equal to nothing but 2 tan x by 2 into differentiation of tan x, that is secant square x, into differentiation of x by 2, that is nothing but 1 by 2. So that is half. So this half will get cancelled with this 2. Okay, and you will be just left with tan x by 2 into secant square x by 2. Okay, and here if you want to simplify it further, you can simplify it further and write it as tan x by 2. Secant square x by 2 is nothing less but 1 plus tan square x by 2. Okay, and multiply it inside and you get tan x by 2 plus tan cube x by 2. Okay, this is the answer for the problem. So a few points to remember here. Okay, I will show you a few points. I will actually note down a few points for you to remember. Okay, let me note them down for you somewhere here. Okay, the points are quite simple actually. The first point is, okay, avoid quotient rule, product rule and quotient rule. Avoid u into v and u by v rules as far as possible. If you can, okay, you can avoid these only if you can use some identities, trigonometric identities. Okay, if you can use some trigonometric identities, avoid as far as possible these two rules and try to get them in some form of trigonometric identities. Okay, the second rule is that the second important rule is that in all cases what you have to do is know the trigonometric identities. Okay, it's very important that you understand and know a lot of trigonometric identities. For example, the easy ones actually sine square x plus cos square x equal to 1, or some of them like cos 2 theta, sine 2 theta, tan 2 theta, tan of pi by 4 minus theta. All these are standard identities in your book, and it is good that you know some of these identities. Comment below if you want me to explain this identity. Comment on the video and I will explain these identities for you. Okay, last is use any other method only and only when you can't use a trigonometric identity. Okay, you should use any other method only and only when you can't use any other trigonometric identities. But basically most 95% of the times when a trigonometric formula is given, it is normally just a reduction into a simpler identity and solution. Okay, so that's all for trigonometric identities, differentiation by trigonometric identities. I hope you had fun. Have a nice day. Bye.